Good morning, guys. Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, Sai.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning.
Shall we start our class?
Yes, sir.
Okay. Right. In our last class, we have seen DynamoDB, right? Before that, we have seen RDS, right? RDS, DynamoDB. Those things we have seen. Now, in today's class, we are going to discuss two services. One is Redshift. Next one is Elasticache. Elasticache. Okay. See, guys, in companies, there will be different teams to maintain them. Separate in that database administrators also, there will be separate team to work on RDS, separate teams to work on DynamoDB, separate teams to work on these things. Okay, again, this class also is just for knowledge purpose. Okay, knowledge purpose and some basic question they ask in certification theoretically further. Because if you want to learn these things, there are some prerequisites, like you should know Linux, you must know Java, you must know any SQL, any one database server. And then if you spend some 3 months, then you can learn, because these are big things. Like, if you know Hadoop outside, yes, to learn Hadoop, these are prerequisites, kind of. Why? Because this we call data warehouse. Data warehouse. I'll tell you what is this data warehouse and all. So these are outside separate courses are there. So database administrators in your company, they log into AWS only, but they work on only these things. Got it? Okay. So just for knowledge purpose, today's class, I have PPTs for that. Let me show them. Okay. Redshift. Come into Redshift. See, guys, this Redshift we call data warehouse. Redshift we call data warehouse. Then what is the difference between database and data warehouse? Simple. It's not about, some people they think that data warehouse means we keep huge amount of data. Yeah, that kind of data we can keep in database also. Okay, database also we can keep any amount of data. But the difference is how you are pulling the data, how you are retrieving the data. For example, these data is there in these rows and columns. Suppose I want to get this value. This way of pulling we call normal database. Okay. Suppose I want the total profit, total output. See, total final output. That way of pulling data we call data warehouse. That means how you are retrieving the data, that differs from database and with data warehouse. Generally, who want this kind of data, management, higher level management. Suppose see DMart is a DMart. If you are an employee, suppose if any employee is there in DMart, what he wants to know that what is the price of that item, what is the price of this item, how many items are there in this stock, that one. But if you are a manager, if you are a head of DMart, then management, what they want to know, they want to know what is the total profit, what is the total sales happened in this month. Okay, what is the loss incurred in this last 2 years. So this kind of data. So who want that data? That's a management, high level management. So when you get the data after doing larger calculation, suppose I want total profit, then they take total, sales, whatever selling happens and the final, whatever, so that's how they get profit, right? So they'll get that data after doing larger calculations, right? See here, use it to pull in very large and complex data sets, total profit, total cost incurred, total expenditure, okay, total loss, like that. Okay, in last 1 month, 2 months, like that. usually used by management to do these queries. These are the query, but management does these kind of things. That's what we call data warehouse. How you are pulling the data that differs from database and data warehouse. Okay. So examples for data warehouse: Cognos, Jaspersoft, SQL Server reporting services. These are the examples. Now, what actually happens in data warehouse? Here, obviously, data warehouse, your requirement is to pull this kind of data. That means obviously in that also you'll have huge amount of data. This is Route 53. Load balancer, web servers. Web servers. Now, if you are using data warehouse, then if you have less amount of data, okay, data warehouse, if you have less amount of data, then you can use single node. When you go with single node, if your data is up to 160 GB, if you have more than 160 GB, then you have to go with multi-node. Up to 160 GB, you have to go with single node. If you more than 160 GB, then you have to go with multi-node. Multi-node means something like this. Okay, something like this. Hadoop configuration also like this only. Hadoop, you might have heard big data one, right? That structure is also same thing. Let me explain. In this blue color portion is data warehouse, this particular portion. Now these are my web servers. Okay. So this is leader node. These we call compute nodes. Suppose, see guys, in a class is here, only some 3 to 4 students are there. Okay, to manage that class, do we need any class leader? No need, right? Only 3 to 4 students. Why do you need separate class senior, class leader? No need. Suppose if a class is there, 50 students are there. Yes, to manage them, you should have class leader, class senior. In the absence of teacher, the faculty, he can, manage the class, administer the class, correct? Here also, when you have huge more than 60 GB, then we go with multi-node concept. In that, we have compute nodes and leader node. Okay, leader node and compute nodes. Now, what actually happens? The purpose of leader node is, the first purpose of leader node is to route queries, I'll explain guys, to route queries. Second one, to have connections. Leader node will not do any task, guys. In a class senior will not do anything. He will assign tasks to students, correct or not? Here also, whenever any request comes, this leader node will route that request. That could be a request or it could be query. See, while putting data, that's what injecting the data. While retrieving the data, that's what we call query. Correct? Retrieving data, we call query. That's what. Okay. So, leader node is responsible to route that, requests and queries. Suppose you want to book a ticket. The train ticket will come here, that, through web server. Leader node will route your request to any one web server, or any database server that will be stored. After 2 days, you want to take the printout. Then the request will come here. Then from any web server, leader node will send to that node only, because leader node knows where your data is. So now you run the query, you take the printout. Okay. So the first one is route requests and queries. Okay. Second purpose of leader node is to have connections here. One side web servers, another side compute nodes. Okay, to have connection. That is a purpose of leader node. Now coming to compute node. What is the purpose of compute node? The first purpose is to store data, where data actually will be stored, where query operation will be performed. Query operation is performed. That means, see, Leader node is routing that request to compute node to store the data, where actual data is. Okay. And second purpose is where query will be performed. Wherever data is there only query operation will be performed. Leader node will route the query. Okay, where that actual query will be performed, that is in node, wherever data is. That's the purpose of leader node. Now, here we have in this data warehouse, we have both concepts are there. Both means both scale up and scale out. Scale up and scale out, guys. Scale up means, see, when data is more, when leader node keep on injecting the data, it grows. Compute node grows automatically. That is what scale up. That is one thing, it grows automatically. Coming to scale out, yes, leader node will add new nodes like this. Like this. There is no limit to scale up. There is no limit. But there is a limit to scale out, that is only 128 nodes max. That's the limitation that they have given. Maximum it can have 128 nodes. And this data warehouse, this Redshift is capable enough to store petabytes of data. Petabytes only as of now. Petabytes means huge, guys. Petabytes of data, huge. But that's the upper limit. But if you take Hadoop configuration also same thing. But that is big data, unlimited data. There is no limit. But here people are using Redshift because fully managed by AWS. AWS will support. I'll tell you all those things. Okay. So here we have scale up and scale out. Both are there. Now, what is the limit to scale up? There is no limit, predefined limit. But who will decide up to which extent, it should be scaled up? Leader node will decide. Leader node will decide. On what basis? Based upon the query operation. Based upon the query operation. That means, I'll tell you, see. Suppose there is a bag. How 100 books are there? Okay, out of 100 books, I can pick any one book easily. But if I add one more book, then it would be difficult for me to pick any book. Up to, okay, let's take 10. Why to take big number? Let's take 10 books. See, someone is keep on putting books in that bag. Up to 10 books, my capacity is 10. That means out of 10 books, if you want me to pick any one book, I can pick easily. But you keep on adding books, hundreds of books are there. For me, it would be difficult to search for one particular book. Correct or not? Correct. That means capacity is 10. If up to 10 only, then I can pick any book easily. Correct or not? Here also, same thing. That is, leader node will keep on injecting the data in compute nodes. Up to which extent, see, keep on injecting the data, it grows. Up to which extent, leader node will decide that if I add some more data, for me, it would be difficult to perform query operation. Leader node will decide that, yes, if I add some more data in this node, it would be difficult for me to perform query operation. To retrieve data, it would be difficult out of huge amount of data. Okay, whenever leader node gets this thought, immediately it will start sending data to other node. So, leader node will allow compute nodes to grow up to certain extent only based upon the query operation. Okay, if that extent reached, then it will send data to some other. So there is no limit to scale up. That who will put that limit? Leader node. Scale out, yes, maximum 128. That's given by AWS. Like this, maximum 128. Okay, so it will route. It will allow node to go with scale up to certain extent. On what basis? Based upon the faster query operation. See, at the end of the day, it's not about storing the data. It's all about retrieving the data also. Suppose you are searching for even YouTube video, okay, but when you give any keyword, but it is not, you are not getting that video. It is taking a lot of time. Then what is the use? Correct or not? So, for running query is very, very important. You should be able to get the data immediately. That is very, very important. So that's why based that on the base of that only, it will allow to go with scale up. Okay, always it will make sure that query operation would be faster. Okay, that's based on that. Now here, what if I lose any one node? If you lose any one node, what actually happens? See, this leader node is right. Leader node has complete details about compute nodes. For example, see, leader, you are booking one ticket, the ticket got stored here. After 5 days, you want to take the printout, then your request will come here. So your request will come to that what particular credentials, right? Then leader node knows that yes, this particular guy's ticket I kept here. So a request will be routed here on. So leader node knows everything about compute nodes. Okay. Suppose class senior assigned one task to one of the students. After 5 days, he will come and say, hey, I have given one task. Did you finish it or not? He knows, right? Because he is the one who assigned that task. Correct. Okay, what if I lose any one of the nodes? Leader node has the complete data what our compute nodes are having, but in a highly compressed manner. Highly. Okay, so that's why if you lose any one compute node, leader node will recreate that node and will put the data here. See the kind of mechanism. So even if you lose any node, leader node will regenerate that node. It will keep the data. Okay, that is so. See the kind of automation which is Hadoop also kind of same. That is. You might be thinking, what if I lose my leader node itself? No, guys, you will never lose your leader node because Elastic Load Balancer, NAT Gateway, leader node, these you will never lose because these are fully managed by AWS. AWS is giving high assurance that you will never lose your leader node. So you need not to worry. But if you take Hadoop outside, that is open source. Hadoop is an open source. So if you lose this node in Hadoop, there is no one is there to take care of that. That's why in Hadoop, there is one standby node. There will be standby node. Okay, so that if you lose this one, all will be connected to standby like that. But here in AWS not required because AWS will take care of this. You will never lose this. Got it? That's so. This is limitation is petabyte only. So always it will make sure that Redshift make sure that injecting data should be faster and also running query also should be faster. Always. Okay. So if huge amount of data is there, leader node has a capability to distribute data parallelly, simultaneously in all nodes. It's not like one by one. No, all in one go. Okay, it has that kind of capability. Understood? Okay. Yeah, you can think alternative Hadoop. Yes. Okay. That is so. Okay, it can distribute data simultaneously, and always it will make sure that there won't be any delay while running query operation. Okay, that is how it is going to work. Okay, let me show you. See, Redshift is a fast, powerful, and fully managed petabyte scale data warehouse in cloud. It's pretty fast, powerful. Everything, operations will be faster, in an effective manner. Fully managed by AWS, petabyte scale. Limit is up to petabytes. Data warehouse service in clouds. Here, leader node, compute nodes. Here we have two concepts are there, OLTP and OLAP. OLAP also we can call OLAP. OLTP, online transaction processing. OLAP means online analytics processing. Normal database operations come under OLTP. OLTP means, see, I need particular value in so and so and so and so column. That means I want this value, this kind of transaction, processing we call. I want this value, this kind of processing. Querying we call OLTP. OLAP means I want total output, total expenditure, total cost. When you'll get this one after doing a lot of analysis only, after larger calculation analysis only you'll get this, right? OLAP means I need sum of values in it. So this is normal database RDS. You can think this kind of transaction happens in data warehouse. Okay. See here, if you have less than 160 GB, you go with single node. If you have more than 160 GB, multi-node. In that we have leader node and compute node. Leader node, it manages client connections. Two tasks, right? I said one is to manage client connections, both sides. Second, it deals with queries. It receives and routes queries. What about compute node? Where data would be stored. That is first task. and where actual query operation will be performed, perform queries and computations. Okay, that already we discussed. So up to 128 nodes only. Okay, that's a limit there that they have given. And say here it is massive parallel processing. There is a advantage in Redshift, that is massive parallel processing. Amazon Redshift automatically distributes data and query load across all nodes. Okay, see, Amazon Redshift automatically distributes data and query load across the nodes. Here, data node, it distributes automatically. Okay, automatically in one go. Okay, data means distributing. Query load means retrieving also, it can be done simultaneously, because see, hundreds of customers, they are booking tickets. Hundreds of customers, they are taking printouts. So it happens automatically, simultaneously, not one by one. So that just to make it fast. Redshift makes it easy to add nodes as your data warehouse to your, see, it keep on adding new nodes based upon the data and enables you to maintain faster query performance. Always it will make sure that there won't be any compromise in running query with high performance. That means there won't be any delay while running query. So always it will make sure that faster query performance as your data warehouse grows, as it grows. Okay, that is so. So that is how Redshift works. As I said, there will be different teams will be there, company, they will take care of that. Okay, but no side, I want to learn this one completely. I want to become a database administrator. Then you have to join any data warehouse course outside, any data warehouse. Okay, so that's of 3 months, but make sure before you join, you must know Linux, MySQL, and Java bit. Then only you can learn. So if you're interested to go in that line, suppose see, I don't want to be AWS administrator. I want to be a database administrator, database. Then you have to learn these things separately outside. Database courses are there. Okay, that is what Redshift. Now coming to Elasticache. See, Elasticache. It is also a different type of database, but this works along with normal databases. For example, I'll give a simple example. Let me use say in this Redshift. These are web servers. This is my leader node. These are compute nodes. Okay, leader node. These are compute nodes. These are my web servers. Okay. Now what we do, we connect all these things. Right? That's it. So here, what actually happens? Suppose you are booking one ticket. Okay. Then your request will come from here, from here, from here. There, that will be stored. Correct? Any kind of data that will be stored like this. Okay. After 2 days, you want to take the printout. The request will come here, from there, you will take the printout. Right? Okay. So here, you have to understand 2 words before we start Elasticache. One is latency. Latency means network delay. Network delay. Second one is throughput. Throughput means passing through someone, passing through. Okay, that's what throughput. I'll tell you. For example, your request is coming like this. See. Okay, to store the data or for retrieval. So latency will be there, correct? Okay, so let's take simple example. Suppose you are giving discounts today. You are giving discounts on one product. Okay, let's take iPhone is it. Okay, iPhone company is giving discounts on one product. Discounts. Okay. Only for today. That sale is only for 1 day. Flat 50% discount. Okay, iPhone 12. That's the latest one, right? 12 Pro Max. Okay, that's the latest one, that costliest, right? Okay, iPhone 12 is that's the latest one, and they are giving discounts on iPhone 12. It's not like everyone will buy iPhone 12 only. There are other normal people, they know iPhone 11, iPhone 10, other series also. But 12 is the latest one. They are giving discounts on 12. Okay. So most of the people, they look for iPhone 12, correct? Because that's the latest one. Few people, they may buy other 11 also. They don't worry about discounts. They want to buy normal phone, so they buy 11 then also. Now, since I'm giving on 12, giving on discounts on iPhone 12, suppose if the product is here, iPhone 12, everyone's customer request will come here. From node, it will go here. Everyone request will go like this to get the details. If they like that product, they buy that product. Now I know that everyone will look for that product only. Then why should their request should come here till here? What I do, being iPhone, that Apple, head of Apple, iPhone company, Apple company, I keep one database over here. I attach on top of leader node. That database is Elasticache. And I keep that iPhone here. iPhone 12, the one on which I'm giving discounts, that I'm going to keep here. So everyone will look for that product. So their request will come here, will take product from here itself. Their request should not even touch my leader node, should not even go up to compute nodes. No need. That means here we are removing the latency. See, earlier the request should travel till here, but now the request will go and here. That means we are removing the latency. Latency means network delay. So there won't be any network delay. They can able to access my product easily, quickly. Only that product only I keep here. Okay, iPhone 11 and all, I keep those anyway, those will be here. If they want to access other product, their request should come like this. Okay. I know that there will be heavy load. Everyone will look for iPhone 12 only. That's why I kept that product in Elasticache. Okay, so by doing this, what I'm doing, I'm removing the latency. Now this database, Elasticache is a database. You can put any amount of data. There is no limit. But this is a caching one. Caching means temporary data. You can store data for temporary purpose only, not permanently. After a certain period of time, data will be deleted automatically. That is how they design. So yeah, correct, right? I want to keep this one only for 1 day only. Because I'm giving discounts for only 1 day. That's why I kept here. You can put any amount of data, but only certain period only. That's a caching. It grows automatically. You keep on injecting the data. Elasticity is there. But caching means temporary data. That's why I'm saying this one, because some of you might think, Sai, why can't you shift entire data to here so that customers can access any product without any delay? No, this is temporary. That's why if I'm giving discounts for 24 hours, then I keep product here. So that after 24 hours, that will be deleted automatically. Okay, so that is all. So here we are removing the latency by keeping that product here, so that instead of request come here, they can access from here itself. The request need not to touch leader node and compute nodes also. So that's the first advantage. We are addressing the latency. Second one is throughput. Throughput means passing through someone or something. Okay, passing through someone or something. That means here, suppose this is one road. This is a road actually. Okay, this is point A, point B, point C. Traffic is coming like this. At A, there won't be any traffic jam. There won't be any congestion. But when traffic reaches B, point B here, due to less space, okay, road is narrow, right? Due to that, there will be congestion. There could be traffic jam. Vehicles move slowly, correct? But here, when they reach C, there won't be any traffic jam, so they can move freely. Due to narrow road here, there could be some congestion because of less space, correct? So here also same thing. When requests come here, they have to pass through leader node, right? Leader node. So all requests should pass through leader node, correct? Due to heavy burden on leader node, sometimes it might pass requests slowly because there will be many. See, here also distribution is there, here also there won't be any problem. But when it comes to leader node here at this place, see, from here to here one speed, but here to here x, y, in that A, B. So from X to A, one speed, but A to B, there will be slow. That latency, that request speed will be less, very, very less because of due to heavy congestion. From B to C again, B to Y, there won't be an issue. So the request is passing through leader node. This is what throughput. Okay. So here also it is showing a lot of time. These are what throughput related issues. When request passes through someone due to heavy burden and all, due to heavy traffic, it might get delayed. Okay. Anyways, the latency is there from here to here. On top of that, the throughput issue is there here. Okay. So that also we are addressing. Why? Because the request should not even touch my leader node, right? The request will come here from it takes the data from here itself. They don't even need to touch leader node. So there won't be any throughput related issues. So by using this Elasticache, we are addressing both latency and throughput. Okay, for that we use Elasticache. It's not necessary that you have to use every number then. No. Whenever you are giving discounts, whenever you feel that there will be heavy burden, there will be heavy traffic, whenever you feel, okay, so for that you can use, that time only you can use Elasticache. What is Elasticache? It is a database that we connect to some other database, like you can think of leader node. Okay, this is unlimited because elasticity is there, but data will be stored for temporary duration because caching is there. Okay. So what we are achieving by using Elasticache, we are addressing latency and throughput related issues. Got it? The simple one. That's one. I have PPT. Let me show that one. Simple concept. Now see this one. Elasticache is a web service, one of the Amazon web services that makes it easy to deploy, operate, and scale. Deployments, we can deploy that product in that Elasticache, iPhone 12. We can keep that product in Elasticache. That is what we call deploy. Okay. And operate means customers are accessing that product. That's what operation. Scale means you can put any amount of data because it is elastic in nature. In an in-memory cache. See, this Elasticache also we call caching engine. Caching engine or in-memory cache. In-memory cache. Either you can call caching engine or in-memory cache. So here, where data will be stored in memory cache in the cloud. That means data will be stored in a Elasticache. Temporary data. Cache means temporary storage. This service, this Elasticache, improves the performance of web applications. Correct or not? Whenever they access website, customers. Okay, that's what improving web application. How? By allowing you to retrieve information from fast managed in-memory caches. That means here. It is improving the performance. How? By allowing you to retrieve information from fast managed in-memory cache. That means see, web servers, leader node, complete nodes. This is Elasticache. See, it is allowing you to retrieve information from where? Fast managed in-memory caches. So it is allowing us to retrieve information from Elasticache itself. Instead of relying entirely on slower disk-based operations. Instead of relying on slower disk-based operations, it is allowing you to retrieve data from in-memory caches. Got it? It can be used to significantly reduce. Okay, what are the things we are addressing? The first one is latency and throughput. It can be used to significantly reduce latency and throughput for many read-heavy application workloads. Generally, we use this data in this Elasticache for read-intensive workloads. Okay, so in that, when you use, you are addressing latency and throughput. Generally, examples are like social networking, gaming. You know that some games become so popular. Okay, so that time you can use that one. media sharing, some YouTube, videos, some videos become so viral, and you are giving discounts on one product. So whatever that content where traffic will be more, that you keep here. Okay. And question and answers portals, QA, like frequently asked questions. Out of 100 questions, frequently asked questions will be 5 or 6 only. So that means everyone will look for these questions. Suppose before you join this course, okay, most of the question, what kind of question you might have asked? What is the course duration? What is the fee? How good faculties? And what we are going to cover? Mostly people will look for that question. Will ask. But some people, they ask many questions. Will you cover EC2 or not? In that you cover elastic load band. So you cover load like that. So these are not frequently asked questions. Frequently asked are only these 4 to 5. So everyone look for that one. So those kind of things we can keep here. Correct? So like that. Okay. So generally we use this for read heavy workloads, application loads, or compute intensive workloads. Kind of same, wherever load is more, where you can use Elasticache. Okay. Caching improves. What it is improving? It improves application performance. Yes, because operations will be faster, right? That means performance will be more. How? By storing critical pieces of data. I'm giving discounts on one product. That means that particular day, that product is my critical piece of data. Right? So I'm storing that critical piece of data where in memory means that's what Elasticache. For what? For low latency access. So what does latency and also throughput? Storing critical piece of data in Elasticache, what does latency and throughput? Okay, that is how. So here there are 2 types of caches are there, which are being supported by AWS. One is Memcached and one is Redis. Memcached is not an open source. Redis is an open source. Like see, for example, MySQL is an open source, but Amazon Aurora is not open source. Like that, Memcached is an open. It's not open source. Redis is open source. Okay. Like that. That is what Elasticache. That is what Elasticache. I hope you understood. Right. Simple things is just remember whatever we discussed. That remember in certification they might ask. Not 2 to 3 questions. That too, whatever we covered, right? In that only, theory article only. Okay. Lab won't be there because no way. You are not going to keep this one in your resume. See, these database things you are not going to keep in your resume. Remember that. Okay. Because they won't even expect these things from you. They look for these things from database administrators. Okay. This is for just for knowledge purpose and certification purpose. Okay. I hope at least you got some idea about database, right? How things work, how connection happens, back and how things work. So that is important. Got it? Okay. Fine. So that is all about Redshift and Elasticache. Okay. So I'll be sharing these slides, in the form of PDF today. Okay. Yeah. Guys, tell me one thing. Actually, we got many holidays, right? Actually, we got many holidays, correct? Is it fine if I take classes? I mean, because this weekend I'm going to finish my 9:30 p.m. DevOps batch. Actually, I'm running one 9:30 p.m. DevOps batch. This weekend I'm going to finish that batch. So is it fine if I take extra classes? Not every day. Whatever holidays that we got, right? In last few days due to my health issues and all. Okay. So next week onwards, if I take a class sometimes, not every day, sometimes, or 9 p.m. or 9:30 p.m. because I'm assuming that this will be convenient because 9:30 p.m. means I don't think so. You'll be in office. You'll be in this. So is it fine? I mean, it's not mandatory. It's all your choice.
We are fine with it.
If it is okay,
We
then
are fine, sir.
Yes, sir. We are available.
Yes, sir. We are okay, sir.
We are okay with the everyday or
yeah. Okay. So okay, fine. So if you are fine, then only I'm fine. Okay. So it's not like a force. Okay. Yeah. Fine. So even anyways, in 1 or 2 days, if you are unable to attend, you are getting recorded videos right every day. So I don't think so. That's a big issue. Okay. So fine. So next week onwards, not every day, whenever we get any holidays and all, not holidays, obviously. whatever holidays we got so far, to cover those days. Anyways, I'm going to take class on 9 p.m. or 9:30. Okay, which timing is good? Either 9 or 9:30?
Sir, both, sir.
Both is
Anytime.
Okay, fine.
any
So,
timing is not at all a
9
problem,
is
sir.
fine.
okay,
9 p.m. sir.
9:30 is fine.
anytime, just it's a matter of half an hour, right? Okay, let's fix at 9:30. Okay, 9:30 is fine.
Yes, sir.
Okay, fine. Okay, that's okay, fine. So next week onwards, I'll be taking some extra classes. Morning will be there anyways. There won't be any doubt. Morning 9 a.m. will be there. Along with that, night also will be there. Not every day, but I'll take some good number of days. Okay, fine, guys. Fine. Thank you. That's it for today. Yeah, next onward. See, by now we covered big services. Okay, we covered all big services. Like be in mute. I will explain. Just be in mute. Whatever we covered so far, right? These are major services like EC2, S3, VPC, IAM. These are comparatively bigger services. But now onwards, we are going to cover these. Now onward, whatever we are going to cover, these are comparatively smaller, comparatively, like SNS, EFS, SQS. Okay, comparatively, not everyone. Few are smaller. Smaller services, it doesn't mean that they are less importance. They have no. They are very important. Even though they are small, they are very important. Some are small, some are comparatively medium size. Okay, fine. So let's see. Tomorrow we'll meet tomorrow. Same time, 9 a.m. Yeah, 9:30 p.m. classes will be from next weekend onwards. Okay, so next weekend onwards, next week onwards. Okay, that anyways I'll intimate you in the group. Okay, yeah, that's it, guys. Pretty much for today. If you have any doubts, you can ask me. If not, we'll wind up class. Yeah, any doubts from anyone?
Hello, Sai.
Yes, please.
Actually, this leader node, no, it will actually route the data and also it will store the data.
No. Leader node will store the data, but in a highly compressed manner. Highly compressed, but actually we should say that leader node will not store the data. See, if someone asks you, hey, where data is stored? Data will be stored in compute nodes only. Leader node also will store, but it's a highly compressed manner, but we won't even consider that. Okay.
Okay, for example, in Amazon, for each and every product, they will be maintaining a node, like compute node.
Yes. Will be there. In Amazon means that's a huge and big one. So
Yes.
that we can't even imagine how big they are maintaining.
So it is faster than RDA. Like,
Yeah, correct. Any more doubts from anyone?
Hello, Sai.
Yes, please.
My doubt related to PEM file. Actually, yesterday by mistake I deleted PEM file. Can we recover it? Yeah, we create new instance.
No, come again. PEM file you're talking about.
Yes, sir. Actually, if we delete the PEM file mistakenly.
Acha, how to recover it?
Yes.
Don't worry. There's a class. We have class for that. Okay, in upcoming class we are going to learn. Okay, if you delete a PEM file, how can you regenerate it? We have class for that. Okay, I'll be explaining in that class. Got it?
So from next week onwards, we'll have. I'm a bit confused. Like 2 times we'll have class, or only at 9:30 p.m. in night.
2 times. 2 times.
Two
Morning
times.
will be there. Evening also will be there. But evening not every day.
Yeah.
Maybe day by day. Like because that's all. Okay.
Okay. Yeah. Thank you, sir.
Just to cover the days because we got some holidays, right? Some 4 days and like that. So just I wanted to cover.
So in morning you will convey to us that tonight we will be having.
Yes. Whenever class is there, I'll intimate you in WhatsApp well in advance.
Okay. Yeah. Thank you, Sai.
Hello, Sai. When we practice on Dynamo topic, it is chargeable.
Yeah, DynamoDB is chargeable. That's why after doing immediately you terminate. You do it only once. You don't do it multiple times. You practice and you delete everything only once. Okay. Yeah.
Okay.
And that's optional whether you practice or not, because anyways we are not going to use this in companies, being a AWS guy. So that is just for I said, right, knowledge purpose only I explained.
Okay.
Sir, where is the Elasticache and Redshift part in portal?
Yeah, here you can see if you log into data under database section, you'll find these things. Let me show you.
So what will be the
Sorry. Please come again. Please come again.
sir? What will be the next services? You
That
will-
I'll let you know because before I teach every service, I verify once because nowadays they are modifying those things. They are adding
Okay.
new things. Okay.
Okay.
That's all. So here you can see under services. Here you can see database. Elasticache. Redshift they modified. Redshift they changed it to some other location. Someone said analytics. Where is Redshift?
It is there in Amazon Analytics, right? Amazon Redshift is there.
Yeah, Amazon Redshift. Yes. Okay, Amazon Redshift is one. Or that's okay. You can search from here. Either you can do Control F or Redshift. From here directly you can get this. Fast, simple, cost-effective data warehousing. Okay, that's all. Yeah. Okay, guys. Then that's it for today. Thank you all. See you in tomorrow's class.
Thank you, sir.
Yeah, have a nice day.
Okay, sir. Hello.